In the last video on the normal distribution, we ended on this problem. The problem says, suppose April scored a 1250 on the SAT. What is April's Z-score and what is her percentile? In other words, of all the people who took the SAT, what percentage of people scored below a 1250? That is the same thing as a percentile. So 1250, in order to get to 1250, we take the mean, which is 1150, and we add half a standard deviation. Her Z-score is the number of standard deviations we add or subtract from the mean. If we add, the Z-score is positive. If we subtract, the Z-score is negative. Since we add half a standard deviation, her Z-score is 0.5. Now, 0.5 in the empirical rule picture we have to the right is halfway between 0 and 1. We said that we can use the empirical rule as long as the Z-scores are things like 0, 1, 2, 3, or -1, -2, -3. That's the only time we can use the empirical rule. Now, 0.5 is halfway between 0 and 1. I can't tell from the empirical rule chart what her percentile is, but I can make an estimate. When Z is equal to 0, that is the 50th percentile. When Z is equal to 1, that is the 84th percentile. Z is equal to 0, that's the 50th percentile because 50% of the graph is to the left. And for Z is equal to 1, that's 50 plus 34, or 84%. So we know that her percentile is somewhere between the 50th percentile and the 84th percentile. But we don't know exactly what number is, but we have a range. On Canvas, there is a document labeled the standard normal distribution, or the Z-table. Let's open that up. So here's the Canvas page, and the standard normal distribution, or the standard normal table, is right here. Let's click on that. And let's download this table. Once you have it downloaded, let's open the table. Okay, now I have the table opened in front of me. Let's read this first sentence. It says the standard normal distribution. Table values represent area to the left of the Z-score. Let me draw you a little picture here. Oops. So here is an example of the normal distribution. And let's say we have a Z-score right here. I'm just going to write Z is equal to, let's say 1.24. So what this table gives me is if I find this value on the Z table, it'll give me the area to the left of that Z-score, or the probability we get a Z-score less than or equal to that number. For example, let's find Z is equal to 0. We know that when Z is equal to 0, that is the 50th percentile. So I'm going to scroll down. You see these numbers? This is Z is equal to -3.9, or -3.9 standard deviations from the mean. Scroll all the way down to 0. Right here, 0.0. You can see that I have 0.5, or 50%. Let's try another one we know. We know that when Z is equal to 1, it's on the 84th percentile, or right around the 84th percentile. So I'm going to scroll down to 1.0. And you see that I have 0.84134. So it's about 84%, like the empirical rule tells us. This one's just a little more accurate. The empirical rule is an estimate. It's not exact. And this one is a little closer to the true value. Now, here on this side of the table, I have Z-scores, but I also have some decimals over here. What do these decimals mean? So for example, I gave you the Z-score. Z is equal to 1.24. Let's see if we can find that. So the first part, I'm going to look in this column here. I'm going to look for 1.2. Let's see if we can find it. Here's 1.2. And then this part, this 4, is right here. So it's like taking 1.2 and adding this 0.04. That's why it says 0.04 here. That'll give you this 1.24. So how we find the percentile is we just go down until these two cross. And here is our estimate. So if I asked you what is the percentile when someone's z-score is 1.24, you would say, oh, that's about the 89th percentile, or about 89% of people, if it was the SAT or the ACT or something like that, 89% of people scored less than the person who had this particular z-score of 1.24. In the problem about the SAT and April's z-score, we said April's z-score was 0.5, 0.50. Let's see if we can find that. So we need to find the 0.5, which is right here. And there's nothing that we're adding on that side. So we're just going to go to the 0.00. And this is her percentile. She's on the 69th percentile, 0.69146. That is what we're going to see in the PowerPoint. Okay, so on the Z table, we had this 0.69146, which is about the 69th percentile. So for April, let me go back to the problem. It said, what is April's z-score and what is her percentile? Her z-score was 0.5 and she's on the 69th percentile, meaning that about 69% of all people who took the SAT performed worse than she did, or she did better than 69% of people who took the SAT. Now, another way to find the same thing is to use Microsoft Excel or Google Sheets. The formula in either one, Microsoft Excel or Google Sheets, is the same. And we're going to try this out. We're going to type equals norm.dist. That's the normal distribution, the command for the normal distribution. And in parentheses, we're going to put 0.5, comma, 0, comma, 1, comma, true. The first number is the z-score. The second number is the mean. The third number is the standard deviation. And the word true means we want to get all of the area to the left of that z-score, just like in the z-table. Let's give that a try. Okay, so here at the top of my Excel page, I just typed the normal distribution formula that we need to put in to get our answer. So we're going to always hit equals, and then we're going to type norm.dist, parentheses. What was April's z-score? It was 0.5. Then we're going to hit comma, the mean. The mean is 0. The standard deviation is 1. And we're going to type true and hit enter. And you see we get that same percentage, 69.146%, or 0.6914. So the answer, whether we use the z-table or Microsoft Excel, is the same thing. Now, I also want to mention that instead of using z-scores, you could also just use her SAT score. Another way to do this is to type equals norm.dist. Remember that her original SAT score was a 1250. Comma, what was the mean for the SAT? It was 1150. Comma, the standard deviation was 200. And we're going to put true. and we get the same thing. So the one on the left is when we're working with z-scores. The one on the right is if we don't want to work with the z-scores, we don't want to normalize our data, and instead we want to work with just the regular mean and standard deviation. If you work with a z-score or if you work with the regular values, you're going to get the same answer. So visually, this z is 0.5, and we're finding all of the area to the left of that z-score. Let's try a new problem. So heights of adult men are normally distributed with a mean of 69.1 inches and a standard deviation of 2.92 inches. What's the probability that a randomly selected man will be taller than 64 inches? The first thing I would like you to do is I'd like you to pause the video and see if you can write this as the probability that z is greater, less than, equal than a particular number. So let's see if we can get there first. Okay, so the first thing I'm going to do is find the z-score. Let's look at the value. A randomly selected man is 64 inches. 64 inches is less than 69.1. So I expect the z-score to be negative. If I subtract, so you see that standard deviation, it's really close to 3. And if I subtract 3, I'll get about 66 inches. So I know that the z-score is going to be less than -1 because it's going to be more than a standard deviation away in the negative direction. So let's calculate it. I'm going to take 64 and subtract 69.1. I'm going to find the difference and then divide by 2.92. That's the formula for finding the z-score. And so the z-score is -1.7466. You can round this to the hundredth, so -1.75. Now I'm looking for the probability that z is greater than -1.75 because the problem says, what's the probability the man will be taller than 64 inches? Taller than 64 inches means to the right of 64 inches. So I'm going to take my cursor, and this value, -1.75, is somewhere between this -1 and -2. And it's not halfway between that, but it's leaning a little bit more to the left because of the 0.75. So let's try to make a little bit of a guess as to what we think this probability is going to be before we put it into the Microsoft Excel or into the z-table. So definitely at 0, that's 50%, and at -1, the probability to the right of -1 is 84%. So it's going to be bigger than 84%, but it's going to be less than 84 plus this 13.5, which is 97.5%. So it's going to be somewhere between 84 and 97.5 to the right, okay, to the right. Now remember that those formulas I gave you for the normal distribution, they give you information to the left. That z-table gives you everything to the left. This problem is asking to the right. Now, in order to find to the right, I need to find the complement. The complement is to the left, and that's what the z-table and the normal distribution will give me. I'm going to do both. I'm going to show you how to find this on the z-table and then show you how to do this with the normal distribution. So let's find the area to the left first. You see that probability z is less than or equal to -1.75. Let's find that on the z-table. All right, we want z is equal to -1.75. Where I left off on this z-table, I was on the second page. I'm going to scroll up to the first page because all of these z-scores are positive. So I'm going to scroll up until I get -1.7. I see it right here, -1.7. In order to get that 5, let me scroll up a little bit more. I have to go over to this 5 here. And now I just need to see where they intersect. And it's right here. I'm going to round to the hundredth. This is 0.04. So the probability that Z is less than negative 1.75 is about 0.04. We wanted the opposite, that it was greater than negative 1.75. So I'm going to take the number 1 and I'm going to subtract 0.04. And I get this 0.96. You see that 0.96? This normal distribution, you can put this in as well, and it'll give you the same answer as what I got off the Z table. Let's check that. Okay, off over here, off to the side, I'm going to type equals norm.dist negative 1.75 for the standard normal distribution. I'm going to type true. And you see I get that 0.04. So that is everybody who is shorter than 64 inches. And then I'm just going to say 1 minus, I'm going to click on this and hit enter, and I get about 0.96. So there's a 96% chance that a randomly selected man will be taller than 64 inches. Let's try another one. This one's a little more challenging, but if you understand this, I think you're doing really well and you understand the normal distribution. We have that Juliet is looking for her Romeo. She is 67.3 inches tall, and she wishes to date only men who are taller than she is. But she's very specific. She wants them to be within 5 inches of her height. So they need to be taller, but at the same time, they can't be too tall. They can't be taller than 5 inches. That's what, for some reason, she prefers. Now let's find the probability that the next man she meets will be in that height range. So what I want you to do is I want you to pause the video and see if you can come up with 2 z-scores, right? Because we want this man to be between 2 heights. So we need to write the probability that z is in between 2 numbers, okay? So pause the video and see if you can come up with those 2 numbers. So what 2 numbers did you get? The first z-score is her height. So she is 67.3 inches tall. We want a man to be at least 67.3 inches tall. So we're going to take that number and subtract the mean, which is 69.1, and then divide by the standard deviation. Now this 67.3 should have a negative z-score because it's below the mean, right? And indeed, it is a negative 0.61. Now the other number, how we find the other z-score, is we take her height and we add 5 to it. If you take 67.3 and add 5, you get 72.3. Now this is the maximum height for Juliet, and we're going to take that number and subtract the mean and divide by that standard deviation in order to get the z-score, and we get 1.1. So we want to find the probability that the man is between negative 0.61 and 1.1 in terms of the z-score. Now our z-table cannot find in between 2 z-scores. It can only tell me the area to the left of a particular z-score. The same thing with Google Sheets or Microsoft Excel. It will only give me things all the way to the left of that z-score, to the end of my normal distribution. So I have to be a little clever here in order to get the answer that I want. So what I'm looking for, this is about 1.1, it's a little bit over 1, and then negative 0.61 is about right. Let's say it's about right here. And I'm trying to find the percentage of men who live between these 2 z-scores. Now, my z-table will only give me everything to the right of the z-score. So if I find the probability z is less than 1.1, it'll give me everything to the left. But I don't want to go all the way to the end of the table here. I want to stop about right here. And how I can stop there is I can subtract this piece. And that's what I'm doing here. I'm subtracting this probability, and that will give me the in-between probability. So let's go to, I'm going to put this on Google Sheets, and again, you can check it with the z-table. Let's find the probability that we're to the left of 1.1 and also the probability we're to the left of 0.61. Subtract the two and see what we get. Okay, down here, I'm going to hit equals norm dot dist, and I'm going to put 1.1, comma 0, comma 1, comma true. I'm going to end my parentheses, and I'm going to minus norm dot dist, and the other one was negative 0.61, 0, comma 1, comma true, and I get about 59% or 0.59. And that is what I have written here on the PowerPoint. There's about a 59% chance that the next man Juliet meets will be within this height range.